Okay. Okay, hello everyone. I think because we still in, this is chapter 3.4, which is the undetermined coefficient. We still have at least two more techniques. The variation of parameters and the Cauchy-Euler techniques. So I think to be maybe to confirm and make sure we are done with all the techniques in chapter 3. That is, I think, necessary. I think the midterm would be, I think, 15 November. Is that okay for the date?
What?
November 15. You also have another schedule? Is it okay? Okay. So now I will give you more details on this techniques. I haven't finished yet. We only give you, I think I give you just one example. Okay. So basically, let me just give you a little bit review on this undetermined coefficient. So undetermined coefficient, if we combine with what we have before, the constant coefficient, the constant coefficient is for homogeneous, right? The homogeneous is necessarily our complementary, that is, it is going to solve the homogeneous. So the constant coefficient will solve the YC, and the whole non-homogeneous can be solved through the undetermined coefficient. So they are somewhat related. So you are going to solve the non-homogeneous also with the previous method to find this YC, the auxiliary equation that you need to have. Like usually you will get some polynomials, right? Polynomials with some degree, either quadratic, cubic, or higher degree as well. So that will be solving the homogeneous equation. Like we have here, we solve this. The first thing we need to do is we make the auxiliary equation, which is how we represent this differential equation in terms of polynomial. So the order will be in polynomial degree. So if this is second order, we will have a polynomial degree 2. So we start by solving the homogeneous part. So we equaling this equation with 0. So we find the auxiliary equations. I think this is just a normal factorization. We find it has this 2m, and we can propose that this m can be put into our complementary solution, this YC. Okay? Then we have this. So this m and negative 1 will be in the power. Okay. Okay. After that, we are going to find the particular solutions, okay, for non-homogeneous. How to find the particular solution? We are going to set some guesses. That is possible. For example, we start looking at this structure, the form. We have E with power of 2t. So we start to have some guesses. What kind of y that we would like to have when we differentiate twice and maybe first differentiate it at the first time, second time, and by itself, it still has the same structure. Of course, if we want to make it this E, then perhaps that is going to be some E with some constant. That is, I think, good guess for our YP. So let this happen. and check with our derivatives as well, the first derivative, the second derivative. And we try to input all those structures into our equation. And then we see that we have this equation that we can simplify, and we can conclude that A is -1, and we propose that yp is -e to the power of 2. So this is why it's called the undetermined coefficient. We are going to find that coefficient. Okay? So we are going to take some gases of the form and then put some coefficient. It can be A, it can be anything, and it doesn't need to be this E. It can be other form as well as we follow this through. Okay? And then after we get yp, we get yc. Then the general solutions we can write yc plus yp. So we can write this. We can write this as our general solution. This general solutions you can also get rid of the constant if we know the initial condition. If we know the initial condition. So I hope you still remember how to just check the value. You can check the value, and you look at the constant, and then you can put the constant here. And there is one note on this solutions. For example, if we have this yc in terms of e with power of -t, and the question is changing to -t, which means that because we already have yc, the same thing, e -t, then we cannot use this yp. So we need to take some other guesses. The best choice is, as usual, if you have like similar or similar forms, you just add another variable, which in here is t. So you just add t, just multiply t, it becomes linearly independent, right? Linearly independent. Hope you still remember that. And then check this derivative, check the second derivative, and then do the same thing. Do the same thing, and then somewhat we can solve this if you solve -2a and -2a, it's become -4a, and then for this ap, we can see that it's going to be 1 minus 2, it's negative, it's minus, so it's plus 2, it's 3, minus 3 become cancelled. It becomes cancelled. So we have this, and we can conclude for this case, we can have this A. So we can also write I haven't written the general solution, but you can see that the general solution is just yc and yp, with A is -3/4. Or maybe let me write on the right side here, just to make sure that we finish this with proposed solution. So yp is -3/4 t e -t. So y is yc plus yp, which is c1 e3t plus c2 e -t, and then yp is -3/4 t e -t. So this is the solutions, the final solution, the general solution. Okay. So the important key in our process is to be able to propose what kind of yp we could have, the form, the structure of yp. And then we check the first derivative, check the second derivative, and put back into the equations. Put back into the equation. Okay, now after this section, we are going to go through for several, I think, necessary examples that we can think. So aside from this E. The other forms like quadratic equations or probability to be sine or cosine, it's the common cases in undetermined coefficient. Okay, let me move to the next page. If you, I think I can wait for a minute if you want to write. Okay, let me give you another example so we can think together. So another example, solve y double prime plus 4y prime minus 2y equal to x cubed negative 3x plus 6. Okay, as usual, we start this example by taking the homogeneous equations. So first, solve homogeneous equations. So 3.4 is really connected to 3.3. So you need to be able to master the 3.3 first to get through this 3.4. So homogeneous equations is y double prime plus 4y prime negative 2y equal to 0. And then as usual, this is going to be using auxiliary equations. This is going to be m squared plus 4m minus 2. I think we cannot factorize this, right? So probably we are going to take some time to let me check the okay. So this will be m plus 2 squared, so this will be plus 4, this will be 6, right? So m plus 2 is plus minus square root of 6, so m is negative 2, m1, right? And m2 is negative 2 minus square root of 6. And we can write for now the yc. It's c1 and then e, we put m1 is negative let me write like that, and then plus c2 okay. So first we get this yc, okay. And step 2, propose yp, okay. Propose yp. So our right side is having a cubic. It's supposed to be it's supposed to be squared. Sorry, squared. Okay. 2x squared minus 3x plus 6. Okay. If it is cubic, it will be very difficult. So our proposed yp, we need to look at the right side. Always looking at this right side, because we want to make this differential going to be equal to the right side. So we need to assume or predict what kind of forms we need to write in yp. So we can propose yp because it has quadratic. Then we could propose that perhaps just propose as a quadratic with all coefficient a, b, c will make sense. Because when we try to derive this, we still get the linear and a constant. And so if we think carefully, all these three, if we arrange in some way, of course this will also connect it to the other quadratic equations, right? It's supposed to be what makes sense, right? It's this proposed yp. So then we could substitute and then substitute yp. Yp prime and yp double prime. So the equations is, let me write equations or maybe copy the equation. Okay, so we could write y double prime is 2a plus 4 2ax plus b, okay, and minus 2 and then ax squared plus bx plus c. Okay, and then this is equal to the right equation, which is 2x squared minus 3x plus 6. Now the rest is we are going to grouping all this x squared, x, and the constant, and then we are going to equaling to the right side. Okay, and we can solve that. I think you need to be careful, okay, with all the algebra operations in this statement. So let me multiply first. Okay. Okay, we start from the x squared. Let me write x squared to ax squared. I think we don't have any other x squared. And then plus, let me factorize x. So 8a minus 2b. And then the rest is plus 2a plus 4b minus 2c. And then we can equaling each variable. So the x squared is here, right? And then maybe take different color. The x is here. And then the constant is here. Okay. So we can equaling this x squared. So negative 2a is equal to 2 for the x squared, right? So a is negative 1. And then 8a minus 2b is equal negative 3, yes. And then the rest is 2a plus 4b negative 2c equals 6, okay? And then we can solve because we have a equal negative 1. So this will be negative 2b. This will be negative 8, move to the right side, become 5, right? So b is negative 5 over 2. And because we have a and b, let me give notes here. So this will be negative 2. This will be negative 10, right? Negative 2c, 6, so negative 12, going right side, 18. So c is negative 9. So we can have our proposed yp as negative x squared, negative 5 over 2x, and then negative 9. Okay, so by this method, now we have yp and we have yc from the homogeneous solutions, right? From here. So we can write the total solutions or the general solutions. Let me write y is yc plus yp. Y is equal, let me copy this, yc and yp. Okay. So this yc, we get it from the constant coefficient. We solve the homogeneous to get this. And this is the yp. We solve through our assumption. Okay, so we predict, we assume, and then we check, we can confirm at the end, and we find all the coefficients. Okay, so that's undetermined coefficient. The idea is we need to have some predictions with some coefficients, with the undetermined coefficient that we want to determine. Okay, and we find the coefficients at the end, and yp as the solutions. Okay. Now before we continue, is there any question? I think the idea, I believe, this method is actually not too difficult. Yeah? Not too difficult to progress. But it takes time, but it's not difficult. It takes time, but not difficult. Because you need first finding the homogeneous, finding yp. I think they are already taking time. And also, this yp, because it depends on the right side of our non-homogeneous equation, right? It depends on this. So we can actually make a combination of this right side. So maybe we have this and maybe we have another key. It can be. That means our yp need to add with another form. For example, if this is quadratic, we have quadratic equations, then our yp has a quadratic. Because if we plug in, it's possible to solve and find the coefficients. Right? If we have the quadratic and then the exponential, then we need to plus this with another coefficient b with e, with another form. So it can also happen. But the idea is still the same. After we propose yp, we confirm and check the other derivative. So first derivative and check through these equations. We check all, and then we determine the coefficient. We will see later if we have those case when we have a combination of the forms. Now the next example, let me write the equations. A y double prime negative y prime plus y equal, we have sine. Okay. Let's just focus on yp. Okay, so determine the yp. But if you want to complete with yc and find the general solution, that's also okay. If you want to find yc, then you can solve this with equal to 0, homogeneous. But I want to focus on yp. I want to focus on yp. So yp, if we have the sign, so we need to guess, right? We need to guess what kind of yp that we might have. So propose yp. Perhaps the very first choice that instantly we can think of is, okay, maybe sine, right? But remember, sine, if we derive, becomes cosine, right? So I think because sine and cosine, they complement each other in the trigonometric, the best way to propose the form is sine plus cosine. So both we need to write, because when we derive, they will each other becomes another sine and cosine, right? If we did first derive, sine becomes cosine, the cosine becomes negative sine, and we derive one more time, they become another cos and sine, right? So I hope you get my point. So when we have this, the logical yp that we can write is a cos 3x plus b sine 3x. Okay, because when we derive, we can check the derivative. This will be negative 3 sine 3x, and then plus 3, oh, I forget to write with a, sorry. Forget to write a and b. Cosine 3x, and then one more time, we take negative 9a cosine 3x, and then minus 9b sine 3x. Okay, now we put all together, so negative 9 as this. Okay, so negative 9a cosine 3x, negative 9b sine 3x. Negative become plus 3a sine 3x. Negative plus become negative 3b cos 3x. And then plus this y is a cosine 3x plus b sine 3x. Okay, and this is equal to 2 sine 3x. Okay, I think we can take some time to check 9a for cosine. So cosine, cosine, and cosine. Okay, so 9a with this cosine here, we can make it negative 8, right? Negative 8a. So cosine, we can write. So cosine 3x is negative 8a minus 3b, right? 3b. Okay. Okay, now the other is the sine. Sine is also negative 8b, right? 8b, negative 8b, and 3a, right? 3a minus 8b. Okay, and this is equal to 2 sine 3x. Okay, now we have sine 3x. Okay, so we have 3a minus 8b is equal to, and the cosine is equal to 0. Okay, so negative 8a, negative 3b equal to 0. And we need to solve this. I think the number is not good number, but let's try to solve this. So we multiply with 8 and multiply with 3. Okay, to make it 24a and need to plus. So we cancel the a, we have equals 16. B is negative 7/3 over 16. And for a, same thing, we'll multiply 3 and multiply 8. And then subtract. So we have 73a and then 6. So a is 6 over 73. So yp is, yes? I already. Right. So this is, a is for cosine, right? Cosine, yeah. Cosine 3x, and the other is b. Okay. So this is our yp. Okay. Okay. I think we can go to next example. Okay, next example is, let's solve y double prime minus 2y prime minus 3y equal 4x minus 5 plus 6x e with power of 2x. Okay, since we need to solve, then we need to find the general solutions. Okay, and notice that the E in our right equations, it has the X in front. So I think to help you guide through which forms that we need to write for our undetermined coefficient, you can try to take the product rule for X and E. You will see that it will become E plus XE. Right? So that's the best guess that this form will have two YP, XE and E. Okay, let me show you. Okay, let me show you. If we have a function that is x and e to x, if you want to take this derivative and take the product rule, this will have e to x plus x e to x, right? It becomes 2, right? It becomes 2 structure. So if we want to equaling this with some yp on the left, then our best choice is we need to include both of these structures. Okay? So that's for this 6x. And the other one, this is just a linear equation. Okay? So we can take this with a linear form for yp. Okay? Like the quadratic we had before. We take the quadratic, and for linear we can just take linear. Okay? So let's try. But first, maybe solving the homogeneous first. Solve the homogeneous. So writing the auxiliary equations, m squared minus 2m minus 3 equals 0. Factorize, right? So we have m equal 3 and m equal negative 1. So YC is C1e negative x plus C2e 3x. This m, you can check the m. You can write because this is actually m1 and m2. You can use m equal 3 as m1 or m2. It's up to you, as long as it's satisfied the question. Sometimes the question has like maybe the lowest one will be the m1. Then you need to take that as precaution. Or maybe they give you some initial value that you can find the constant. So we have the YC. So secondly, propose YP. So let me give you the 4x minus 5 plus 6x e 2x. I think I need to have 2 here, right? Okay, forgot. Okay, now this part is a linear, right? Linear, just a normal linear equations. This part is the exponent. Or linear, we can say also polynomial with degree 1. So we can have yp is yp1 plus yp2. And yp1 is just the linear. It's the linear. Yp1 is just a linear. So we can take like a, using a, x plus a constant b. Okay. And in yp2, as we mentioned before, that is x e to the power of 2x, this will require 2 structures, right? 2 structures. So we will have plus cx e to x plus d. Well, sometimes to avoid d becoming the differential, because we have d as operating, so let's skip d and write e instead. Okay. But you can write with any coefficients. Like maybe you can write with s, r, but usually this is just to help us arrange the solution. Let's try this as our yp. Let me write here, this is the linear, this is the exponent. Why this? Okay. Okay, let's take derivatives. So this will be a plus c, the inside will be e to x plus 2x e to x, right? And then plus 2e e to x. Okay, and then another derivative. So a becomes 0. And c and e to x is 2e to x plus this will be 2e to x plus 4x e to x, right? Plus this will be 4e small e to x. Okay. Okay, and then what is the equations? Let me copy. I think I will write here. So y double prime I think we write carefully plus 2c. Oh, I think we can write 4. We can just combine these two. Combine become 4e to x, right? Okay. So 4e to x c, and then plus c for x e to x, and then plus e. Why it's really long, and then negative 2 and minus 3. Okay, minus 3 of the, oh, I don't have space. Minus 3ax plus b plus cx e to x. Okay, I think we need to move this a little bit to the left. I think that way. Move here and move there. Okay. I think we can simplify this first. Wow. Okay. this also minus, right? Okay. Wow. C3 so let's start with e to x first. Maybe start with e to x. 4c plus 4cx oh, I think for x, e to x will be another groupings, right? So let's start with e to x. So 4c, 4e, okay. And then what else? Minus 2c and minus 3e, right? So we can have this 2c plus 3e, right? Oh, plus, is that plus? 2c plus 3e. Let me check for e. Okay, let me just write this. Okay, and then the other one is x e to x. This is 4c negative 4c, so 0, and then negative 3c. Okay, I think that's all. Yeah, we can continue after the break. Well, I will finish this and we can continue after the break. Okay. Let me check. I think there is something wrong here. Oh yeah. But let me check the derivative here. Is this correct or not? This is 102. So this should be plus e, right? Okay. Okay. Yeah, we can have. Okay, continue a little bit. Okay, just to finish off these questions. So we can, using the structure equaling to the our equations, 4x minus 5 plus 6x e with power of 2x. So we first equaling the, I think we can start from the 4x. So x is this part. So negative 3a is 4. So we can start with that. We can write down that negative 3a is equal 4. So a is negative 4 over 3. Okay, we can start from there. And we can also start writing the constant. This is equal negative 5. So this will be 8 over 3 minus 3b, right? And then we can move this become negative 23 over 3, and this become 23 over 9. And not really good number, but this is the b. Okay, and then let me move this to the side. So a, b, and the other one is this x e with power 2x. Okay, so we have the negative 3c is equal with 6. So c is negative 2, right? And for e power 2x, 2c minus 3e, this is equal to 0. So negative 4. So 3e is negative 4. So e is negative 4 over 3. So yp is negative 4 over 3 x minus or plus here to 23 over 9, and then minus 2x e 2x, and then minus 4 over 3 e power of 2x. So this is yp. So we can write the general solutions. Let me copy this part. So this is the general solution. And then we add the yp. Here you can check again with your own derivatives and try to compute if there's mistake in my solutions. But I think now it's okay. Yeah. But there is a weakness, okay, or some precautions, okay, for this method. It is about the if we have, first is duplicity. If we have a duplicates, that is, we are going to make sure that the components is linearly independent. Okay, we need to make sure of that. This is the second weakness is, for some cases, we need to check our YP whether it is fit within our solution or not. Okay, because sometimes when we propose YP, we put in and suddenly maybe it becomes 0, so that we cannot use that YP. Okay, let me give you one example. Okay. Okay, let me give you one example. If you have y double prime minus 5y prime plus 4, this is equal 8e with power of x. On the right side, we have 8e with power of x. Of course, if we have this equation, we perhaps, with our instinct, maybe we say that we need to use yp a e with power of x, right? Maybe that is our proposed yp. So let's try to write that. But if we find the derivative, they are still the same, right? They will be the same. Okay. So this first derivative is still the same. Second derivative also the same. Okay, now let's try to put, so a ex minus 5. So they have all the same components, right? So 1 minus 5 is negative 4 plus 4 is 0. Now this is the problem. So there is some weakness in this method. So that's why we need to make sure that our proposed YP is not contradictory. They need to follow this differential equation. So to avoid this, then perhaps we need to make sure that this form is, again, we can compose this E like we did before. The technique is just adding another variable and multiply with x, for example. So let me write here. If yp prime and yp double prime substituted, then it will be 0 equal to 8ex. Okay, this is contradictory to original DE. So therefore, yp equal a e to the x is, how to say that? Is wrong guess. So we need to take another YP. The best choice to make sure that we still have e with power of x, but linearly independent, is try yp x e to the x. If we try this, then we are going to have right, and then another second derivative. We are going to we have 2a ex plus ax ex. Okay, if we try to put into the equations and then sub so 2a e with power of x plus ax ex minus 5 and plus 4. Okay, I think we can solve this. Negative 4a ex, negative 4, okay. Two minus 5. Oh, 2 minus 5 is 3, sorry. Negative 3, and this is equal to 8ex. The other one is cancelled, right? So a is going to be negative 8 over 3. So yp is negative 8 over 3 x e with power of x. Okay. I think there are only two weaknesses: the duplicity and when you have the exponential. Okay, now let me give you the sum table, some assumptions or predictions that we might need. And this is also you can try for some differential equations. So this is a trial for some particular solution. So if we have a constant, then the form is just a constant. So it is a coefficient a. If you have a linear equation, we have also linear form. If we have this quadratic, we also have the quadratic form in the yp. If we have another polynomial like higher degree, we will have also the cubic. We have sine or cosine. We are going to have both in plus equation. So we have cos for x plus sine for x, and have coefficient a and b. And same thing when we have cosine. We have exponent. Remember, okay? It will depend on how it turns. Okay? So sometimes if it is going to have some duplicity with the homogeneous solution, then we need to add x. Okay? We need to add x. Or if they are having more m in the homogeneous, then you can maybe adding another x squared. So as long as it is linearly independent and makes sense in our structure. Now, from number 8 to number 12, this will be a combination that might come up in the problems. So if we have a linear and then multiply with the exponent, then it will be linear and it multiplies with that. Right? I think you can follow that. And you have, when you have the x squared, e with power of something, in this case 5x, then you will have a quadratic. Remember, we need to write the polynomial with a complete coefficient. Although this is just x squared, we need to write our assumptions, our predictions with complete coefficients with bx and c. We need to include all of that. And also, if we have an exponent multiply with sign, we need to multiply this cosine and sine with the exponent, each coefficient, and we need to multiply with the exponent. Okay. And if we multiply the polynomial, if we multiply the polynomial with the sine, then each of cos and sine we need to also with the quadratic, with the polynomial. The polynomial, it doesn't need to be quadratic, it can be third degree too. Okay. Then we need to add another coefficient, but I think it would be really long, right? But it's still possible, And if we have a polynomial, an exponent, and a trigonometry, we can multiply all these three. So that means the structure, the base structure is sine and cosine, right? And then both will be multiplied with the polynomial and exponent. Okay. So as long as you can identify these equations and writing the correct assumptions, this problem in undetermined coefficient will be easy. Okay? Will be easy. I think not difficult, but maybe it takes time because we need to write a long equation. But as long as you keep on track, I believe you will solve the solution. So when you try this, maybe I will give you exercise later. Maybe after Thursday class, I will give you some exercise to help you to go through most of the possible problems in the undetermined coefficient. As long as you can first solving the homogeneous, which is actually the previous techniques, right? And also propose the particular solution and find with the undetermined coefficient, and you combine both of them, you can get the final solution, the general solution. Let me give you an example from here. Okay. Let me give you an example. Okay, we need just to focus on YP. Okay, this is similar to what we have in the polynomial multiplied with exponent. So this part, right? It is very similar to this part. This part also similar. Yeah, I think number 9, right? Number 9 here. So we need to multiply the polynomial and multiply with the exponent. Because we have e and e same factor, so we can write this and maybe factorize first, making it so we can propose yp is ax cubed plus bx squared plus cx plus d, and then e with power of negative x. But you need to check this yp, check if there is a duplicate in yc. You can confirm that. Okay, I'm just showing you how to find the assumptions. Okay, and if we have another part, another questions, another forms, if we have y double prime plus 4y, and then is equal to x cosine x. Now we have x cosine x. This is similar to number 11. We have a polynomial x, and then we have the trigonometry. So we need just to multiply and then adding sine plus cosine. So the best proposed yp is, since it's linear, remember to write completely as in linear equations. Okay, that's our yp. Okay. Our yp. If you want to check finding this the general solutions, you can try. Okay. And also, after we get this, you can also check if we have a duplicate in yc. Remember, if we have a duplicate, then we need to change our yp. Okay, now let me go through, give you another example. Now this example, we can combine all the forms in the table. Okay. Okay. So we have 3x squared, 5 sine 2x, and xe with power of 6x. So we can, if you would like to write like really long in a horizontal line, it's still okay. But if you want to make sure we are tackling all the YP, maybe we can separate YP1, YP2, YP3. Okay? So let's say we have this. So we can have YP1. It's a quadratic, so we can have ax squared plus bx plus c. And for the sign, we can have YP2, which is the e cosine 2x plus f sine 2x. And YP3, we have done this x and e, so we have g xe 6x and h e 6x. And then we can arrange all these YP in a long horizontal line. Again, you can check, especially for the exponent, because the exponent is, I think, the one that might have the duplication because of the homogeneous solution. If you check the complementary solution from here, well, we can check right away. So we can check from here, m squared minus 9m plus 14 equals 0. We have, I think, negative 7, right? And negative 2. So m equals 7, m equals 2. So yc is, let's say, c1e2x plus c2e7x. I think it's safe. It's safe. 2x, 7x, it's 6x here, right? I think it's safe. But if we have like 6x here, then we need to change a little bit here in the proposed solutions and multiply by x. Okay, another one. Okay, try to find YP. Okay, we just have this e with the power of x. Okay, I would like to know how you approach this questions. And all the examples I show you are using still the second order, right? Second order. It can also be in the higher order as well. We have the third order, fourth order, which means when we have our proposed YP, we need to differentiate into third time, fourth time, 5 times, and then substitute again. Well, of course, it will really take time. So I think for your exercise, I think it's okay. You can try your best to understand the concept, the process. Okay, since we have done similarly with the previous notes, if we check this E with form X, if we just take some A, that's our proposed YP. If we check here, it's going to be 0, right? So that's not the case. So we can check with AX, EX. So if we check, so try YP is X, A, X, EX. So we take the first derivative. So XEX becomes AEX plus AXEX, right? And then the second derivative will be 2A E and then AX e to the power of X. Okay. Well, before we try this, don't forget to check the YC. So check the auxiliary equations. That we have is this. So M is equal 1. And we might have duplicity, right? So we need to write YC is C1 EX plus C2 XEX. Now, this XEX is equal to our YP. So this is also not our YP. So we need to multiply with X squared. Okay. So this is wrong. Let me write here. So wrong guess. So I think the safest YP is taking the X squared EX. Okay. I think you can try that as well. I'm just showing you where the duplicity might happen, and also the first one is when we try just e to the x, we see some contradictions in the differential equation, we see some duplicity, and then we need to take another approach, that is we need to have this x squared e to the power this yp. Okay, I think I will end up until here. Okay, I will end up here. Do you have any questions? Okay, there is a few sections left, just for some 1 or 2 examples more. Then we can move to another techniques. So this is better guess. Okay. If there are no questions, then I think we go to the feedback page. Okay. If you still have maybe more discussion, you can have after class, or you can send me an email.
If you derive YP to YP5 and the YP5 is the same as the YC,
Yeah, still okay. You need to be careful on YP only.
so only YP.
Yes. Okay, I think we can start. Yeah, using the just code. Okay. Okay, I can wait here. Okay, I think we can start now. Okay. This is just for the homogeneous one, the constant coefficient. But it has some polynomial problems, so you need to have some good performance on polynomials. Let me help you. We have m cubed plus 5m squared plus 3m plus 9. Okay. First, you can check the possible roots. Plus minus 9, plus minus 1. Okay. So plus minus 9 becomes plus minus 1, plus minus 3, plus minus 9. That's all the roots that might have been an answer. You can check all of it. And then because all is positive, there is no variation to change. There are no positive roots. Okay. Right? Right? That is one way to look at the polynomials. I think you can learn from other tutorials as well how to narrow the roots from the polynomial function. And the rest is you need to tailor your possible roots. The question is, will there be a duplicity or not? Like it has the roots that has the same value. Because we have 3 roots, right? 3 roots. Or we have all distinct roots. If you remember the synthetic coefficients, that is, I think that is the best way to solve and find the roots. I think I've made a mistake. So, for if you feel you can find the answer. Sorry for this. I think I made a typo. But the question should be there is one minus. So this one positive. So I think it's still. So. Yeah, it should be negative.
It should be at the 1 minus.
Yeah. Okay, yeah. Don't worry about this one. Okay. Sorry about that. Yeah, it's supposed to be A for if this negative, but let me just I just skip this one, okay? Okay, I will go to the second one. Okay, I also check with my okay. I don't think. Okay, the question is okay. Question is okay, but what about the answer? Okay. The question is okay for the second one. The first one is having a typo. Okay, so the initial value is, if you remember, we need to look at this x equals 0, right? So we can plug in later to fulfill the equation and then find the constant. But I think as long as you find the components, I believe you are able to pick your options. So I need to solve the quadratic m squared minus 2m plus 1. Okay, I think it should be. You can look at this the form, right? Okay. Okay, I think. Who is Snuggles? Snuggles? Who? Huh? No one? Who is this one? Is it? No? No? So who? Okay, okay, that's okay. Okay, now is the attendance. Okay. Maybe someone from outside. Right. Okay, if you have any suggestions, you can also ask, or maybe some requests. Okay. So yeah, 15 November. I think that will be our midterm. So next 2 weeks, midterm, next 2 weeks. Yeah. So yeah, 15. Okay. Because we need to cover all the chapter 3.